So on last week's meeting, I was saying I had my garage door opener installed and it will, let's see, share screen. It's supposed to connect to the Wi-Fi in my house, and they give you some kind of a phone app that you can then apparently open and close your garage door from anywhere in the world. Now I lost my screen. Can you see a web page on your screen right now, Al? I think he said yep. So anyway, this is what we looked at last week, and this is the brand of the garage door opener I have, and it says it's a quiet Wi-Fi garage door opener with wireless keypad, and it has they give you the little controls here, which I should show this when I'm not in full screen like this, but it just the little thing here they're showing you. You push the button and the garage door opens. So you put that in your car, and then it's got the panel on the wall, the button on the top, say that opens and closes your door, or there's a button that turns the lights on and off, and there's a little LED to give you a status of something. And then you can download this thing for your phone that lets you connect through your home Wi-Fi to this thing. And apparently you can open and close the door and maybe get status whether it's open or closed or moving or something. So let's see, what was the point of bringing this up here? So this is what I talked about last week, saying, I could have my robot or my lawnmower open and close the garage door. And then I was looking at it more, and it turns out that on YouTube, people are saying, and I'll post a link to this search, but everybody's saying, well, the MyQ doesn't work very well, or it doesn't fit in with your home automation software. So everybody is buying this board. Here's this little board down here, and it here's a guy showing it. He's got a little adapter he's hooking up to. Anyway, you wire this directly into your garage door opener. It's got some terminal strips on it, and you hook the two together, and then theoretically, your home automation software can now talk directly to the garage door and open and close it, and give you the status back on the thing. And so everybody's saying, "Well, I got rid of my queue, and then stop it." And then I installed the new board, and that's what everybody's going down the line here saying that's what I'm doing. And I was thinking about that, but I decided that if I start wiring stuff into that garage door opener and anything goes wrong with it, or they just see it on there, they're going to tell me that I have screwed things up, and that then that's a problem, and they're going to hold me responsible for it. So I think the easiest way, let's see, I showed the garage door, I showed these modules, and then the GitHub is this. Stop it. Come on. Oh, I'll post the GitHub link later, and it talks about this thing, and you can see right here from this picture. It's just simply it's got the module. Stop it. It's got the module, and it's got a terminal strip, and it's there's a little IC on there and a USB connector. So there's really not a whole lot to it. You could probably go to the GitHub and get the software, and if you already have one of these ESP 8266 modules laying around, you could just build one yourself. But I'm thinking that the easiest way, I was saying before, that if you just take one of here, how to stop sharing? Just take the little thing here, and it's just a thing that's got a clip to hook onto your visor in your car. And basically, if I push that button, my door opens. If I push it again, the door closes. And I was thinking that way you don't have to make any connection at all. So if I just take one of these, if I take this, solder wires on the push button inside, and then hook it up to whatever I want, I could just run this controller. But I decided, rather than, again, I don't want to hack on the ones they gave me, because they're going to complain about that. So I looked on, you go to the page for Chamberlain, it says, here's how you order spare parts. And it said, oh, go to Home Depot and get it. And they want, for this box, they want $32 for one of these boxes. And I said, that seems kind of expensive. So I go to Amazon and look and punch in some stuff. And there you can get 2 modules for $14 or $15 or something like that. So for $7.50 instead of $32, I can theoretically get a box that I can then tear it apart and hook wires onto the push button. And when you go to order, it says this only works with the yellow button opener or the purple button opener or some other opener. And it turns out that if you go watch the videos or look at the pictures, to train these things, you have to push a button on the back of the garage door opener. And then you take this thing while you got an LED flash, and you push this button, and that locks the two together somehow. So it's not like back in the old days that had a bunch of dip switches. You randomly pick something. It's got some fancy high security stuff that this control is then locked to your garage door opener. And I don't know if it changes over time or how that works, but I just assume, again, I shouldn't have to figure it out, because if the thing I have works and I just hook wires up to it, then that would allow me to do that. So that's probably the approach I will take. Is if I decide to do this, I'll just go to Amazon and say, send me 2 controls. And when they show up, I'll go out and see if I can make sure I can program them that they will indeed open and close the garage door. And at that point, then I can just tear one apart and solder wires on it. So that should work.
Sounds like a cool project.
And then also I thought, is if you have one of these, I can put this, you just put it right on here somewhere, say stick it on right there. So it's just like when you have it in your car, you go get your garage door, you push the button, it opens. Well, as the robot drives around, it would have the controller right on that. Or I could tie it in, put it anywhere in the house and tie it into a computer on my network. So theoretically, I could do like the other people are doing, where from anywhere in the world, I can say, tell me if my garage door is open or closed, and then say, well, let's see that. I guess at this point, I don't have any way of knowing if my garage door is open or closed. So I could put like some put a magnet on there and put some of those little reed switches on, so I could collect extra information that way. But for right now, just to open and close it, that'd be the quickest thing. Just simply take one of these and pretend I'm pushing the button, and that should make the thing work. So that, I guess, if I get the ambition to do that, that'll be the next step. And I think I showed those 2 web pages, and I'll post the link to GitHub when I'm done here. So that takes care of that one. Then also last week I was saying, because Al was talking about driving his lawn tractor around to do his mowing, and was saying that his lawn tractor's speed is affected by either how much grass or he's going uphill or downhill. And I kept saying, I don't think it should do that. But the only way to really know is to verify it. So I was thinking about what you would need, to run an experiment. So if I were to take my lawn tractor and I'd want to instrument the engine. So first of all, I want some way to set the speed of the engine, and you can either, mine's just got the little handle on it, so I could just set it to a position. It wouldn't be real critical at this point, just for testing, but just set it to a position. Or as Al has done, he's taken that handle off, just put a piece of wire on, so he pulls the wire to the speed he wants and twists it down. So his is always set at his requested speed is going to be fixed all of the time. So even if he turns it off and turns it back on tomorrow, the engine should always be set at the same speed. So that's the first thing you want to do, is be able to specify the speed of your engine. And then it'd be nice to be able to read the RPM of the engine. And we talked about that either on this group or the ROS agriculture group. If I think about it, I'll post a link to somewhere where we were talking about that. And on mine, I can either put some sensors on the flywheel, because the flywheel is going around, it's got magnets on it. So you can either put like Hall effect sensors, or you could just put like a coil of wire and then have some electronics to understand the pulses. But anyway, you should be able to get engine RPM by reading that. And then also on mine, on my alternator, it's got 2 sets of windings. One winding goes through a diode and then connects right into my electrical system to charge everything. And the other winding is simply comes out, hooks up to the 2 headlight bulbs on the thing. So it's putting out an AC signal as the thing runs. And I should be some simple electronics. I can take that AC and convert that into pulses. And again, check the RPM based on that, just by counting, pulses per second or pulses per tenth of a second or something. And if I've got the cover off, I may as well go ahead and put more than one type of sensor on the next to the flywheel, and then just leave the wires hanging out, so I can do, when I get around to experiment, I'll have that stuff. So that's the second thing. You want to be able to read the engine RPM. So as the thing drives along, you can see if the engine speed is varying up and down, based on what the load conditions are. And then I thought, what you really want to know is, how is the governor on the engine trying to respond to what's happening? So on the cheap cheap little lawnmowers. I got the little, gas powered push mower, and the small engines like that have an air vane governor. So it's just got on the flywheel, it's got the fins sticking up to make a fan, and then that fan blows air across the engine to keep it cool. So they just put a piece of plastic in, a hinged piece of plastic in the airflow. So the faster the air is moving, it tries to push it back like this. And then over here you got a spring that's pulling it this way. So the air vane working against the spring uh, comes up with an equilibrium. So you pull on the spring so hard, and then as the engine speeds up, it pulls on the spring, and it'll reach a point. So it's just like doing the electronic PID, the software PID control. This is just a mechanical version of that, where it's probably just proportional control. But anyway, you pull on that spring, and then the arm comes like this, and then as the engine runs, it pushes it back like this until it reaches the point you want. If you want to run faster, you pull on the spring harder. It pulls it like this, and the engine speeds back up, and it'll come back to the point where it wants to be to match the speed you have requested. On the bigger, fancier ones, it's got internally in the engine, it's got some kind of probably centrifugal weights that are spinning, and it's got an arm that comes out the side. So it's got like on the side, it's probably got an arm about this long, sticking up like this, and it's got holes in here. So there's a connecting rod that runs from here over to your carburetor over here. So it's got one on there. So they move together like this, and then they put a spring in there somewhere. So it works just like the air vane one, but it's a more industrial version. And they got tighter springs on, which I think Al has noticed on his. He was saying he's going to need a bigger servo to pull on the thing than like on my little push mower. I just use a standard servo on that one just to pull it. It's just a little tiny light spring. You just have to pull against that. So that anyway, that is a way to that's how the thing works. Now it might be good to know what position that's in, and then so I didn't put some kind of a sensor on that. I can use either one of those Hall effect shaft sensors like Al is using to measure his back wheels. So on the carburetor, inside the carburetor, it's got a thing like this. It's got this like a what do you call it? The throttle plate turns like this and either obstructs the air or opens it up and gives you a lot of airflow through there. And that's usually got a shaft down through the middle of it. So if I just put a magnet on that, put the sensor, I can tell how far the carburetor is open. Because what you could see there is, let's see, was there anything else I wanted to? I guess that's the main things I was thinking about. So you want to be able to set a speed and then go out in the yard and drive around. I guess to eventually do this, you want to know what your vehicle speed is. So you can either measure say if you have encoders on your back wheels, you can get the speed from that. Or if you have GPS, you can get the speed. So in this one, I got my GPS back here. And as you're moving, it reports how many, I think you put out kilometers per hour. The ROS drivers, they convert that down to meters per second. So you can just pull that right off and say, how fast am I moving? So your experiment could be set up where you say, set the engine to whatever arbitrary speed you want, and then go out in the yard and start driving. So if you drive from the sidewalk into the grass, that's going to put a load on the engine, at which point you should be able to see the engine RPM is going to drop off. So you come in like this, the engine RPM is going to come down like this, and then you watch the throttle plate, and then the throttle plate will open up, and as it opens up, then the engine speed should come back up. Yeah, I'm sure this makes absolutely no sense with a point like this and everything's backwards. So anyway, as you move into the grass, the engine will slow down, and the governor will see that, and it'll pull the carburetor back open, and it should go back to whatever speed you had set. So depending on the brand of the engine and how well they worked on this, that's going to work more or less optimally. And I think on my lawn tractor, I know that one. I noticed when you put a load on it, all of a sudden it kind of goes bang and exerts like 14 horsepower to go from whatever RPM you are to whatever you wanted. So it seems very responsive, and I'm thinking it should maintain the control for the speed fairly well. But I'll have to set up this experiment to try that and see what it does. And then we can try it on Al's lawn tractor and whatever else we can find around. So anyway, by watching the engine RPM and by watching what the carburetor is doing to adjust for that, and then watching how fast the engine or how fast the vehicle is moving, from that you should be able to derive, is it is it the mechanical governor on the engine that's not maintaining the speed, or is there something in your drivetrain? Because I'm not sure on the hydrostatic transmission how much, a load on hydrostatic transmission affects anything. But that would give us all the tools to then set up an experiment. You go out and you can drive up and down hills or drive in grass and out of grass. And there's really two things on the lawnmower, because the amount of grass you're cutting is affecting the load. And then if you're going uphill or downhill, that affects the load. So you got those two things that are trying to change your speed, and then your governor is trying to maintain the constant speed on the engine. So that'd be interesting to set all that up, and then just define an experiment that says, here's what we're going to do. And then also you can go back, if you're watching on GPS and saving the information, you can say, well, I was at this point in the yard and it started slowing down. Then you can pinpoint that and say, based on the GPS, that's I've got, like, say, a ditch in my yard, or I've got a hill that I'm going up, and whatever. So that would just be a way to instrument all this stuff, and then come back later with a ROS bag file and say, what was it all doing? You can plot it all against each other. And if nothing else, it'd be kind of interesting to see what the plots look like at that point. And then Al was saying what he needs to do, because his assumption was he's going to have to go back and electronically monitor his vehicle speed and control the engine throttle to control that. Well, now keep in mind, now you've got two controls, two closed loop feedback systems are going to be working against each other. So the one on the engine is supposed to be maintaining it, but if it's not, then you start modifying, the governor, and those two they're actually working against each other when you do that. So that's just another thing to consider once you start digging into that. So you won't really know until somebody actually proves, how well does an engine maintain the RPM based on any particular load that you have. So I guess for the moment, that's all I have to say about that. So I guess any questions on that, Al, before we move on?
No, I mean, thanks for the thoughts. The I am not at the moment. You described it perfectly. I have pulled the wire back to get the RPM of the engine, at a sufficient level to turn the cutting blades fast enough to cut grass. And that never changes, and it always comes back to the same thing. It'll be a long day in the future. I mean, it'll be well into the future before I try to control the RPM, but I think you're right. Having something to measure the RPM to know that it is either it is or is not staying consistent would absolutely be useful piece of data for me. Because right now it's not certainly visible if to my ears. I think I just mixed two different senses there, but it's not audible to my ears that the engine is changing RPM as it's going up and down small hills. And I'm just trying to control the speed via the transmission servo.
Okay, so that's something I can put on my list of things I'll never do, is to go start modifying my engine to see how that's going to work out for me. I think I could put something right on my little push mower, but that would give me some information, but not as much as, I don't have a way to measure. I don't have a way to measure speed. The only thing in there I could do is, by watching the blade, watching the engine RPM as I cut into the grass is the only thing that would really tell me there. But that would give me an indication of what the air vane governor, how well that works, and as opposed to the bigger engines that have mechanical governors on them. Because you could probably tune the governor somewhat, because usually it's got this arm sticking up, it has multiple holes in it, so you can take the rod off and say, move from this hole up to this hole, and it gives you a different mechanical advantage. So that's effectively adjusting the proportional gain of your feedback system by doing that. And if you get set too high, then it's going to start, the engine will start hunting, and it'll go roar, and you get too low, that it's going to run really nice, but as soon as you put a load on, it'll go and pull down and won't correct for itself, because I don't think there's any kind of an I integral factor in the control system. So, but
Hmm.
that's something probably you look on YouTube and say, show me adjusting governor on my lawnmower. They may, explain how all that stuff works. And it could be I'm completely wrong on that, but I'm thinking that's, from what little I know about all this stuff, I think you should be able to adjust it somewhat. And you just have to decide if that is your problem. If your engine RPM is not staying constant, you could probably adjust that to get it to work better. But I guess we won't know until somebody actually tries this.
You're right.
And right now you have the ability, you don't have a way to measure your engine RPM, but you have a way to measure your vehicle speed. And I you could actually tell if you're going uphill or downhill. Pull up the information from your IMU, look at
Hmm.
the tilt and the tilt and roll values from your IMU. You should be able to tell, or pitch. It's actually the pitch value that you want. So if the thing's going uphill, you get one number. If you're going downhill, you get another number. So that would give you an indication of how much load you have based on that. Another interesting point, as I was thinking about this while I was out mowing my yard. So I had my little push mower. I've got this weird grass on one side of the house, and I'm cutting way too low. And what happens is the grass starts building up underneath, and it gets to the point where it starts loading the engine down, because the engine, it's got like 3.5 horsepower engine, and it can't keep grinding the grass. I keep building up more and more inside of it, so I have to stop and bang the mower up and down, and all the grass will come falling out. And I need to, some of the mowers have like a hole in the deck where you can put a garden hose in there to clean out your deck. I should just drill a hole and then carry a 2 liter pop bottle around, and just pour water in while it's running to try to blow all that out of there. But it's the point where it loads it down enough, it will kill the engine if I don't, back off and then bang on it to get the stuff to fall out. So that's just
Hmm.
another interesting factor there. So
I,
that's all I've got, I guess.
I definitely have that problem when the grass is wet. It seems to load up. Uh,
Yeah, right now my grass is wet, and this grass is really thick. It might be what's called orchard grass, and I'm cutting it way too low, so the grass is somewhat wet, and it's real juicy grass to start with, and I'm cutting it too much of it. So that I got several things there that need to be addressed. I think I'll just raise the thing up about an inch or so, and I'll probably have much better luck trying to do that.
well, I have a number of problems, and I think probably the easiest way to talk about this is maybe starting with the lowest level sensor. But a couple of days ago, I went out and did 5 different tests um, and saved the bag files. And this is just one of the bag files that's loaded up. It's not anything in particular, but when what I labeled here RC mode is when the remote control is in position 2, that's when it's in automatic. So for this time period, um, I was trying to run an automatic, well, the pure pursuit algorithm, and the mission that I had planned was, trying to be executed. Um, and so that was 182 to 263. And this is what the speed looked like in that period. It was, let me get rid of, there's 3 speed values here. One's the left wheel, one's the right wheel, and one's the average of the two.
Is this
And
is this live right now, so you can add something to that? Because you have a
yes,
topic,
I
you have
have
a
plot juggler up.
yeah, you have a topic just simply called speed. I think that's your speed for your GPS. So you can try plotting that on there too, and see if that speed matches your wheel odometry speed.
Yeah, I don't know if that was in my um
Yeah, I guess you might not have it on this particular incarnation of your stuff here.
And that's not a, I've got to go find out why that's not, it's not in there. You're right. I used to have that, but there's velocity, but that's a twist message. That wouldn't be my, yeah, I think I got a issue with why that's not showing up. But anyway, so you can see in this 182, right? Was it 182? Yeah. In that time period, the speed is not, it's going up and down, up and down. So I don't have speed control. And then I got to looking at the data. I'm like, what in the world is going on here? I'm getting negative values in my speed, in my so that's another problem. I was just trying to expand this back out to see what the over in this time period. So then I got down low into my embedded code on my speed sensor and was adding some print statements to try to figure out what's going on with that. And I'm not where I thought I was going to get decimal numbers. I should have realized that. Well, do I have the print statement here? I just put in if the meters per second was a negative number to print off position movement. And I was just trying to get the sensor reading to see if I was skipping some reads, because I'm only doing this at 2 hertz every 500 milliseconds. But current position was coming out in what looked like binary a binary format. I couldn't understand. It wasn't apparent to me why I was getting that data in as my current position when I thought it was going to be just a 14-bit, 0 to whatever that is, 14,000. So bottom line is I've run a couple of tests. This is a screen print, so this isn't live data. And what the ODOM data was telling me, it's just all over the board. So I've got to go back to largely to square one to say what's going on with this speed sensor and why would I get what looks like reasonable data that because, it is starting and stopping during this period, but during this period, it's giving me crazy, crazy numbers. So yeah, I'm like, I'll get it fixed, but I'm back to a really low level problem at the moment. So out there testing, getting data, trying to understand it, wrestling with my speed sensor at the moment. And as soon as I get that resolved, I'll wrestle with my PID settings, trying to control the transmission servo.
On the left there, you got an entry that says GPS array data. Do you know offhand what's in that? Is that one of those that's just like 1 through whatever?
Yeah.
I
So
just wonder if you have a speed in there somewhere you can pull up.
I don't know, but we can open up the Miro board and find out. Oh, the other thing that I wanted to show while that's loading is a couple of weeks ago, I physically had a wiring problem. And so it got me thinking about my microcontroller that's on my tractor. And we'll go back to the speed thing. And I found another board designer or PCB designer that would let me have some expansion. That's probably not the right word, but to let me mount the microcontroller, but then have some access. So I use this EasyEDA to create a PCB and ship that off, and it should be here tomorrow, which was
Uh,
about a week later.
did you remember that your holes are too small for your microcontroller?
Um,
Like,
yes,
yeah, the first board you made, the holes were too small; it wouldn't go in or something.
I mean this one of the nice things about, and this is really just a test because it's hard for me to. I guess I probably could have dug a little deeper, but their library for parts seems to be better, and so it'll be a test to see how good all of this works. But I'm hoping their library is a little bit better than the Fritzing library was for the particular TTGO board that I'm using. So anyway, next week I'll be able to report on that test. But back to Miro board. And this is just where I keep some documentation. And so Jeff asked me the question about that particular array, and I don't have it memorized, but I do have it written down in this Miro board. Speed is speed in there, boy. I'm gonna say yes, but only about a 60% confidence factor. So we'll see.
I think that original speed topic that you had was being published by whatever your GPS.
To ODOM.
Yeah, I think it was originally got stuck in there, and if you swap that out for something else, you might have just lost that along the way.
Doing this. Well, this one will be close enough. Oh, I hate when this does that. See how this is not in that box? Something. But the GPS data is over here to the left. Doesn't look like, of course, over ground. Heading, y'all, course over ground. No, not there. Speed is not there. So I could add it, but I go back to my I can just, nope, that won't be there. I don't want to be in documents. Come on. Spell it right. Nope, don't see it in there anymore. Wonder what happened to it. Maybe we thought well, I don't know what happened to it. I'm publishing the left and right speed, but not the combined or the average speed. I could put it in there, but anyway, back to your question. You were wondering what the difference is, right?
Yeah, I just wondered if your wheel speed is matching what your GPS says.
Yeah, it's been a while since I looked at it, but when it's going straight, it's pretty decent, but I'll go back and add that in. So positive news out in the yard, running it, testing it. Challenges. Do you have any thoughts on why I would be getting a value like that for current position when basically just trying to read my sensor?
Well, I assume you're reading a binary value from your sensor, and that is going to be whatever comes off there. So,
Yeah, but I've not had.
just looking at that number you showed doesn't really mean anything to me.
I wonder if I look at the right side. Is this or that's node 5, node 6? Wonder what the difference is between those. Yeah, that looks like it's spitting out the same thing. Now, could something have changed? Anyway, I won't debug in real time like you guys, but I was expecting that number to be one between 0 and like whatever 14 to the second power is, which I think is 14,465 or something like that.
It's probably 16,384. I think is what
Okay, there you go.
it's just simply being displayed as a binary number as opposed to a decimal number. If you convert that into a decimal number, then you'd see your number you're looking for. So whatever your print statement's doing, at that point you could say, show it to me as binary, show it to me as decimal, and that you can put it out as both, and that way you won't have to do any more conversions. You'll have them right there in front of you.
Yeah, that'll be the fastest thing to try. And then I guess the last thing I was just going to mention is so this weaving back and forth. I'm also wondering about how well my IMU is working. Now, in one of those 5 runs, I came out and, about up in here, I turned on the auto mode and it didn't really waver. It just sort of hugged right along that line. And I'm thinking, hey, this is great. Um, and not much changed between this run and this run as far as my settings go. Certainly, I don't think I changed anything enough to warrant, such erratic behavior. And I'm nervous that my IMU, because the way that I have to run my IMU is I have to take it back to the starting position where I have a known heading, and reset my IMU and set the offset. And because of that, it's got me wondering about reinstalling my BNO85 from Adafruit, which I have in my left hand here, and I'm moving it around. That's why those numbers are changing, which gives me the heading and 2 or 3 and gives me in 3 different formats. So anyway, I was playing with that as well. That IMU is this one. That wonder what they're currently selling that for. It doesn't. I guess I'm not on the price page. So along with the speed, getting consistent speed data, I'm double checking my IMU data as well.
You were
Lot,
saying, earlier, when you would drive around the perimeter, so I assume you're driving it nice, fairly long straight lines, and apparently you have enough contour to your yard that this was happening. You said, while it's doing that, it sounds like the engine RPM is staying constant, but
yes,
you could see the vehicle was physically changing speed.
right, because the servo, yes, to your question, yes, absolutely, because the servo, in this particular, at this moment, the this is the this is the data that's being transmitted for the servo, the transmission servo control. So it's varying between 295 and 325. And as this number changes, the hydrostatic transmission is being adjusted, trying to get to this consistent linear X setting of 0.75.
I thought you just had fixed locations that your RC servo would go to, and then they would stay there.
A month ago, you're absolutely right. That's what I was doing. But because that was not, because it was going up and down the hills, the engine sound wasn't changing, but the speed was literally stopping. I couldn't find a, this again is the value being sent to the super servo controlling the hydrostatic transmission. I couldn't find a value that could operate the tractor in anything remotely tolerable. And by that, I mean, it would either be going too fast or it would stop. That's why I was, a couple of weeks ago, 3 weeks ago, started to try to implement a PID to control the super servo connected to the hydrostatic transmission. Do I still have you?
Yeah. So I guess I wasn't paying close enough attention to realize that you had two different ways you're controlling the transmission. It switched back to a different mode.
Yeah, it switched from the 4 presets to now trying to configure a PID to handle that super servo. But all hell seems to have broken loose after on my just monitoring my speed. Oh man. So it's definitely causing me to go back and re-understand all my sensors and how they're wired and how they're working. Anyway, that's where I'm at.
Okay.